Let's consider Kirchhoff's laws of spectroscopy. Gustav Kirchhoff, not knowing about energy levels in the atom, coined the term black body radiation, and he also postulated three empirical laws that take his name. These laws are illustrated here. The first law says that a hot, dense gas produces light with a continuous spectrum, either a hot solid or a hot, dense gas. That's what you see if you look at the light produced by a hot source or by a lamp through a prism. You're going to have a continuous spectrum. The second law states that a hot, tenuous gas produces light with emission lines at discrete wavelengths. So you have a diffuse hot gas here, pass the light through a prism, and then you're going to see emission lines. The third law says that a hot, dense gas surrounded by a cool, tenuous gas produces light with a continuous spectrum which has gaps at discrete wavelengths. So you have a continuous source viewed through a cold gas. That's the source here, the source that in the first law would produce a continuum. If you see it through a cold gas, you're going to have an absorption line spectrum. So let us understand these laws. Already from looking at these three laws and comparing them to the spectrum of the sun, you realize that a star is an example of the third law. You see a continuum with absorption lines superimposed. So that tells the stars have something to do with the situation of the third law, a hot source viewed through a cold gas. That means that the light that we're seeing from the sun comes from an interior that is hotter than the atmosphere. The atmosphere of the sun is at 6,000, but it's much colder than the interior. So that already tells us a little bit about the structure of stars. You have also the very upper atmospheres, which are an example of the second law. When you look at the spectrum of the solar chromosphere, this is a flash spectrum, a spectrum seen during an eclipse. Then what you get in there are emission lines. So that's clearly an example of a hot and thin gas obeying Kirchhoff's second law. So let's understand how these laws come to be. Let's first start with emission and absorption. You're seeing here an example of that. These are nebulae. This is a reflection nebula, this is an emission nebula, and these dark bands are absorption lanes. Let's just understand what is happening here.